Oh wait, did it work? Okay, cool. All right. So, how's everybody doing?
Good.
Yeah, not bad. I guess it's the weekend.
Fine.
Yeah. All right, cool. So real quick, how much progress have you guys gotten so far on SolidWorks? Like, I don't really know. I haven't been to the CAD lesson, so I don't really know what they've covered. So, like, how far have you guys gotten?
From watching the recordings, I believe we got up to assembly, or we did assembly.
Okay, so you guys you have tried like making parts, right? Like just like just like messing around for a bit.
Yeah.
Yeah, we did a little bit with Red.
Okay, all right, cool, sounds good. So what I wanted to do was like have you guys like work alongside me. So oh wait, let me share my screen. All right, I completely forgot about that. Yeah, all right, cool. So what I wanted to do was have you guys like work alongside me. So then instead of just like you like just looking and listening, we actually all like work together. You know what I mean? So that way, if like any questions come up as we're doing it, you guys could just ask it right here, right? So that sound good with everybody?
Yep.
All right, cool.
Yeah.
All right, so I guess first everybody get SolidWorks open up real quick. Let me just put this over here. All right. And so what I wanted to do, what I had in mind was kind of similar to something similar to the miter thing, right? So that way you guys have a little bit of a better idea on how to do the miter based off of this, right? So another gearbox we have, well, it's actually only on Rev A, right? But a gearbox that we have is the portal gearboxes, right? And so these are literally like just 2 gears, as simple as it gets, and 2 gears, 2 shafts. That's literally it. There's one in, one out. Nothing fancy, nothing complicated about it. So it's pretty simple in terms of design, and I think it will give you guys a pretty good idea on how to get started with the miter, right? Because it's not exactly the same thing. The miter is 90 degrees. I keep on calling it bevel and miter. I'm sorry. It's it's just kind of confusing to swap between the two. But yeah, I wanted to try out the portal gearboxes. So I'll show you guys. I'm trying to find where it is in the files real quick. Sorry. I'll show you guys what it looks like on the car. Yeah, like the final product. And so we'll try to make something similar. Where the heck is it? Oh, there we go. Okay, so this one and then front gearbox. Right hand side. Yeah, let's do this one. Okay, here we go. I'm opening it up right now. Okay, here we go. So this is a portal gearbox, right? And well, it's one side of the case, right? The whole thing. I can open up the whole thing real quick. This is what the whole thing looks like, and we can just pray that there's no errors real quick. Ah, didn't pray enough. That is very unfortunate. Okay, well, is this? Hold on, I think this might be a better. Don't say this. There we go. This one is a little bit happier. Okay, so this is what a portal gearbox looks like. The reason they call it a portal gearbox is the reason they call it a portal gearbox is that you basically have this input shaft and it gets just moved back a little bit. So typically what they use stuff like this for on cars is if you really, really need ground clearance, right? So you can imagine it typically being like set up like this, so that way like the second gear is directly below it. So if you have like an axle and like the differential is like way up here, you want to keep it away from the ground so you can lift it up, have it connect to this, and then have it drop down, have the wheel connect down here rather than up here. So that way you give yourself a little bit more ground clearance. So this happens typically on like tractors and stuff like that, and like really fancy pickup trucks that do super dirt rally stuff. I don't know. But basically, yeah. So that's what they use it for. In our car, instead of moving the wheels down, we actually just move them backwards to give it more room for the steering. So yeah, we have this set up on our Rev A car, and if I hide this, you can see the inside is not correctly catted with gears. Yeah, I'm sorry about that. These gears, this toolbox for gears is very not want to worky, but basically you can get the idea. Imagine these gears were the gears that were supposed to be the correct size, right? You can see that this side's a little bit bigger than this side, and that's because this gear is bigger than this one, right? So we have a little bit of gearing done here, and then also just to, the whole goal of it's to push the axis backwards a little bit. So yeah, there's that distance. So basically, what I was thinking we could do is making this right hand side, right? This one half. I think it would be a pretty it probably would be a pretty good example for the next minor gearbox, because you basically do kind of similar things where you're going to take measurements and whatnot, right? Do you guys have GrabCAD installed, and is it like working for you guys? Don't have it installed? Okay. Does anyone else? I'm just curious. You don't need it right now, but do you guys have it like working / installed, or what's the situation?
I have it in, but I was having a little trouble with it.
Oh, like log it
got
in, right?
Yeah.
Yeah. It gives me trouble too. Okay. So, all right, that's fine. The only really thing that you need other parts for are like measurements, which I can still show you. Okay. So here, I think we can get started now on the new part, right? So, making something like this is going to be the end goal. This isn't going to be too complicated. I'm probably going to simplify it down a little bit, just for time's sake, right? But you don't really need super duper fancy geometry like this. And honestly, this is not even like something that complicated. There's not really that many features here, but we're going to make something basically similar to this, right? So everyone just open up a new part, right? And I'm going to make this in inches. All right, cool. And the first thing we want to do, right, is we want to start off with something as basic, or a sketch that gets a majority of what we want, like feature wise, right? So like the primary feature here is obviously going to be like this kind of contour right here. I don't know, like, yeah, like you see the highlighted orange part, right? So this contour is like basically what we want to work around. So like, for example, the gears have to fit in this space, right? So we have to make sure that this is we want to start with this first, like the most critical feature. That's how I typically go through it, right? That's like the way I think of it. But yeah, I try to start with like the most critical feature. And so for me, that's going to be this contour out here, because the gears have to fit in there, right? So that's the easiest place to start from. Stuff like these little these are slots for bolts, right? This can honestly be moved around and whatnot after the fact, right? So something like the position of these bolt holes aren't as critical as like the dimensions around this contour, right? So that's typically where I like to start. So the first thing you do is you go in and you make a sketch, right? So I think that's pretty simple, and we want to make these fit certain dimensions. So I'm going to throw out some random numbers, right? And we're just going to use them for an example's sake, right? So let's say we have two gears and they're 2.5 inches in, well, one's 2.5 inches in diameter and the other one's 4 inches in diameter. I'll just put that in the chat right now so we can remember that. 2.5 in smaller gear, and then 4 in big gear. right? Do I click part or assembly? Oh, okay. So, so you want to make a part right now, right? So if I go back to this thing, right? So if I go back to this part, this is an assembly, right? This assemblies are composed of parts, right? So you want right now you're thinking like, do I want to make a part or an assembly? And you want to make a part right now because you're starting like with nothing. Usually when you make an assembly, you first need parts, right? So this is basically where you start. So this component right here is a part, and you can tell the difference because these little icons over here, these tell you if it's a part or an assembly, because you can have an assembly of assemblies as well, right? They're just called sub-assemblies. So over here, you can see there's 6 things, right? There's these yellow T's and then a yellow T with a blue cube. And the blue cube, when it's there, that means it's an assembly, right? So in this entire assembly, right, because there's a blue cube here, you have 4 parts, 1, 2, 3, 4, and 2 sub-assemblies, right? So if you click on the sub-assembly, you'll actually see that in here there are parts, right? And so there's 1, 2, 3 parts in this one. This one's technically 4. The reason it's a tool is because that's the gear, right? And the gear was made using another feature called Toolbox, and it's supposed to make gears that fit for us. And you can see how great that worked out. Yeah. So whenever you make an assembly, it will, at the lowest level, it's always going to be parts only. So like this is like the lowest level assembly we have because there's only parts in here. And then you can put other assemblies inside assemblies, and you put also parts in there, right? So you want to make a part right now because you're making something from scratch, basically, right? So the long short answer to your question is a part, right? So start there. All right, so everyone caught up so far? Everyone good? Put this over. Okay. All right. I'm going to assume that you are all good. If you have, if there's any questions, I have the chat open on this other monitor, so I can still see them. So, okay. So we want to start off with that basic contour, right? So we can go in and we can make a circle for the big gear and another one for the little gear, right? And right now you could just, you just make 2, right? So go in, click the circle, make 2 of them. And then have you guys been taught, what do they call? Relations? Have you guys been taught that yet? Constraints? Yeah. They're basically constraints relations. I think they're called the same thing, right? You guys know how to, yeah. So, okay, yeah. So here we can apply constraint because we know we want these 2 circles to be lined up, right? So we can click the center of these 2 circles, and that basically dictates the whole thing, right? So you do a control click, so that way you select both of them, right? And you could go in over here and you can see that you can merge them, you can fix them wherever you are, make them vertical, horizontal. Typically, we don't really use fixed because fixed doesn't really give us any mathematical relationships. It just says keep it where I put it right now, and you typically use that if you're doing something a little bit more like temporary. Yeah, that's the word, right? But for now, we want these 2 lined up, right? Actually, we can also include this middle one because it actually will help us as well, the origin of it, right? So if we select all 3 of them, right, the origin and the center of the 2 circles, you could click horizontal, right? And now we see they're all on the same line, right? That makes things really, really convenient. I like typically putting stuff in the origin. No reason not to. It just makes stuff cleaner. You know what I mean? Right? So there's that. The next thing we could do is get the get the two circles connected. So you can see that there's this line, right? Well, it has like an oblique oval shape, right? So you have to connect those two circles in order to get that. So that is just a line from here to there, right? And then you do the same thing on the bottom. And there. And now we have something that's starting to look like it, right? So everyone following along so far? Am I going too fast or anything?
Yeah, I still can't get it to line up with the origin.
Okay, so when you click the 3 points, right? So you click the 2 circles, right? And then also the origin, right?
Yep.
Yeah, all right, cool. So then what happens when you click horizontal?
I could only click them one at a time. I don't know how to click them.
Oh, okay, so hold down control while you're selecting
okay.
all of them. Yeah.
I see.
And then let me know if that works for you.
All right, cool.
Yeah, right? All right, cool. Yeah. Super helpful tip. That's a pretty good one. All right, cool. Everyone else good and caught up?
Yeah.
All right, cool. All right. So now we kind of have something that's starting to look like it. We could also see how things are constrained by moving around, right? So you can see over here, you could just change the size of this thing, right? And also over here, we can select the center of this. You can see we can move this back and forth. So that shows us how we need to constrain these things, right? Actually, well, first, before I start with that, let me just do one final thing. This trim entities thing, right? So trim entities, if you can see the little GIF that's going off right now, basically it's like a magic tool where wherever you hover your mouse and cross over, it just deletes those lines and the points connecting it, right? So we're going to want to use that right now. Power trim is like the most useful one. There's a whole bunch of other ones that are a little bit more specific, and I've actually never really used them. I've only used this power trim one because it just works like 99.9% of the time, right? So what we want to cut out is this inner semicircle, right? Because once we cut it out, then we'll get a shape that's pretty similar to the one that we want, right? So for right now, we can just select the power trim tool, and you can just literally cross right over it, right? And that's it. It's just gone, like exactly how we need it, right? And then you cut out both sides, and you can see that it's just the way that we want it. It's the shape that we need it. But if you actually zoom in, you'll see that there is this weird little thing where these lines are not really where they like need to be. So what we could do there is another thing with a relationship. So we can select both of those, right? And then you can click merge. And if you click merge, you'll see that it actually brings the two together, right? I think that actually, let me see. I think if we click this and then the two lines as well, another way you could do it is tangent. And tangent actually works a little bit better here because that will ensure that there's a smooth transition, right? So you can see over there. Oh wow, this actually made it like that. Okay, yeah, we can do that over there and do the same thing on the bottom half, right? And make those two tangent. And now we just have an oval. Okay.
Wait, for some reason I'm having trouble trimming.
Okay, all right. So you click the trim entities, right? And then the power tool, the power trim one should automatically be enabled, right?
Mm-hmm.
Okay, so let me go back. Right, okay. So trim. So this is where you are right now?
Yeah.
Okay, so all you have to do is just hold down your mouse button and then just cross over the line you want to cut out, right?
That's very strange. It's not doing that for me.
Is it not?
Yeah.
Can you share your screen?
Let me see. It says host disabled participant screen share.
Oh, hold on, let me see. How do I disable participants? Hold on. Pause share. All right. How about now?
Still says the same thing.
What does it read?
Host disabled participant screen sharing.
Disabled participant screen sharing. Oh man, I feel like a professor. Share computer size. Jesus Christ. No, wait. Advanced. Wait, how do I actually allow? Wait, allow participant to unmute their name. What the heck? Okay. I don't know. I'm trying to figure this out. I'm sorry. Okay, so what happens when you try to cut something out?
When I put my mouse, it just highlights the entire circle. So maybe they're not connected. The line isn't connected to the circle.
Wait, so can you say it again? Sorry?
So when I put my mouse over the area I want to cut off, it highlights the entire circle.
Okay, well, you want to start outside of the part that you want to trim, right? So like you see where my, oh wait, hold on, man. All right, sorry. You see where my mouse is right now? It's like out, it's off the line. So you start over here, you hold your mouse down, and I don't know if you can see that little gray line, but that's where my mouse is moving while I'm holding down the left click button, right? And you just go right over it.
Oh, you have to hold down your mouse.
Yeah,
okay,
yeah.
That's so strange. Okay, got it.
Okay, cool. So now it's good?
Yeah.
All right, cool. So we could, hold on, sorry. Okay, cool. So that's that side, and then you can do the same on the other side, right? And now we should have a shape that looks like this, right? The next thing you could do, I think it'll be, you want to probably do tangent one. So I know I said you can merge those 2 points, but it doesn't actually come out clean. What actually comes out cleaner is a tangential mate. So a tangent mate will make sure that when this line connects to this semicircle, it goes smooth, right? So we can click on the lines themselves, right? So you want to click on the line that's going in and the line you want to connect it to, highlight both of them by like control clicking, and then you can do a tangent, right? Like that. And then you could do the same thing on the bottom, right? And then also it shows up here too, a little like quick mini menu, right? This first one here, make tangent, like that. And then now we should have something like this. And let me just see if I can do this real quick. Make this like 2.5. And then I make this one 4. Oh, no, it won't work. Hold on. Why won't that let me do that? Tangent there. If I do... Hold on. I'm trying to
Maybe
see
it's
why.
because you chose the middle of the circle, like that middle line.
Yeah, because I wanted something like, like obviously like the shape before, right? So here, let me delete these 2 lines because that's the ones that give me issues. And if I just click here and then connect it to somewhere like there. Wait, what's that point there for? Oh. All right. Sorry about this. I'm still trying to get it. All right, there we go. All right, so now let's see if I can connect these 2. All right, if I put it like that, and then I make another one down here. So that tangent, right? And you can see when I make the line, right? So for example, I click there and I make the line. You see those 2 little squares below like the pencil? That shows what constraints I'm going to apply when I like make this line, right? So the first one is like a little T shape with a circle inside. So that one means coincident. So that just basically means that the two lines intersect, right? And then you have another one that is a straight line up and down, and that means a vertical. So it's going to be vertical to some key component of the line, right? And so that probably will be the center of the circle. I moved it over a little bit, and then now on the right you can see it as a circle with a line that goes to a circle with a line that's like tangent to it, and that one is basically saying it's going to be mated tangentially, something like that. Right? So okay, I think this actually worked a little bit better for some reason. But yeah, okay, so now I think I could like say I want this one to be in diameter 2.5. We set it on the smaller one, and then the bigger one has a diameter of 4, right? Something like that. And so now we define both of those circle sizes, and then we can go in and trim them. Now it looks a little bit nicer. There we go. Right? So, everyone good so far?
Inches, right?
Mm-hmm.
Okay.
Doesn't really matter too much. It does matter when you're making something that's actually, like a final product. But like math-wise, a lot of the stuff just like works out the same. You can actually this thing's actually pretty smart. So like over here, for example, I typed in 4 inches, right? Let's say I wanted to subtract it by 35 millimeters. I could literally type in minus 35 millimeters, right? And the thing is smart enough to know what I'm talking about. So it still does it fine. And you see like my final result is still in inches, but now it's like a funky number because of that millimeter thing, right? So it's pretty smart. So, all right, so there's that. Let me see what happens when I do the tangential stuff. So this one already has a tangent. Oh yeah, okay. So you can also check what kind of constraints your thing has. So like I said, I wanted to see if this line was already tangent to this circle, right? So I highlighted both the line and the semicircle, and you can see this one box, existing relations, tangent, right? So I know that these lines are already tangent to each other. I could check the same thing on the bottom half, right? And tangent. Okay, now this side over here, tangent and tangent. Okay, cool. So all these 4 corners are tangent to each other, which means that there's a nice smooth transition between this line to that line. So when I go in and manufacture this thing, I don't have to worry about there being a sharp edge somewhere, right? So that's good. So now this is like the basic shape that we want, right? And then we could also go in and do like something kind of similar again, because we actually need to make a case wall, right? So by making the way we make the wall is just like repeating the same process, but making it a little bit bigger, right? So you'll see what I'm talking about, right? So I go in, I'll make a circle here, and I'll make a circle there. And by having the circles when I first made them, I used the center of these circles. So that way the SolidWorks automatically knows, like, make these things on top of each other. And so, and constrains them to be forcefully on top of each other. So if I click this circle, see how both the semicircle and the full one I just made move together, right? It's a new constraint I just made on them. So they both move all together, right? If I click it from here, yeah, there you go. Yeah, that's bugging out. Okay, all right. And then you do the same thing over here where you take it and just line it up over there and take this line over here and connect it over there. Right. And then you can go once again with your trim tool, cut this part out if it wants to. Cut this out, cut that out, cut that out. Now you got to cut all 3 because it only cuts one section at a time, right? So got to cut all 3 out. There we go. There. And now that looks a little bit more like it.
Wait, can you go over that entire part again?
Okay, right. So let me back up. So, blah, right there. So what I want to do is make the wall thickness, right? So you see the space from here to there, right? That's like the wall thickness. It's actually a little flange, right? But if I get rid of, suppress this one, and let me suppress this. There we go. Right. So this wall thickness is what I want to make, right? And the way I do that is, the way I'm going to do that is just by making the same thing, but a little bit bigger, right? Because it's literally the same exact geometry, but a little bit bigger, right? So that's exactly what I'm going to just do. I'm going to redo it by adding in more circles and then just connecting them with lines. Again, same thing as I did before, right? That's just it. Oh, oops, that one's not tangent. Tangent, there we go. I'm going to make this tangent as well. There. And now these all should be tangent, right? That makes sense? Or did I lose you again?
Yeah, makes sense.
Okay. Okay, cool, right? Yeah, just literally redoing the same thing, right? And so then we got to go in with the trim
I have a
tool.
question.
Mhm.
Yeah, how do we know like which point to select on the circle? Because it's not like the middle.
Okay, right here. So let me go back. So I can select whatever point. What the heck? 4. I can select whatever point I want, right? So let's say I make my next circle over here, right? That's fine. And then what I would just have to do is, because you need to make sure that the 2 circles you make that are supposed to be like perfectly overlapping do perfectly overlap, right? And the way you ensure stuff like that is by using constraints, right? So I can't just really like move this here and be like, oh, that looks about good, right? Because very clearly it's not, right? So what you can do is you can move it, and you see how it snaps to the center, like this little cross right here, right?
Yeah.
This little cross is the center of this semicircle, right? So if I drag this one on top, there's now that little yellow square, and it's 2 circles on top of each other, right? And so that little yellow square is basically saying, make these 2 circles perfectly. They call it coaxial, right? So on the same axis, right on top of each other. It's actually also concentric. Yeah, basically just means like put these 2 circles so that their middles are perfectly lined up. So you can do that.
For the line like that you're about to do, like after you make 2 circles and then you connect it with the line. Like how do you know where to place that line?
Oh, okay. So that's also another thing with the whatchamacallit, the constraints, right? So the first one, you could pretty much put it wherever you want, right? The only thing I don't recommend is putting it on this little dot, because it will force it to be on that point, right? And when you're doing stuff that you want tangent points aren't always going to be like on these four corners, if you want to call them, right? So I typically like putting it on the circle, because I know for a fact it's going to go on the circle, but just not at these points where I'm forced to keep it at that point, right? So that's where I start. And on the next one, I want it to be tangent, right? Like I can do the tangent mate myself, but like it's a little bit more convenient when it's already tangent when I click it, right? So if I go hover again on the circle, just wherever, do you see those 2 little yellow squares to the bottom right of my pencil? Right? Those two yellow squares show the constraints that are going to be applied. So so the first one is the coincident one, which basically means that the line will intersect with the circle, which is like a no duh. That's what we're going for, right? And then the second one is the circle with the line that goes like right next to it, and that one tells us it's going to be tangent, right? And that's what I want. I want a tangential line. So I'm going to click it, and you can see here, if I click the line and the circle, right? Existing relations tangent, right? Okay, so that sounds good. Does that make sense?
Yeah, sorry, I was doing the sketch.
Okay, yeah, no, you're good, as long as it makes sense. All right, cool. So then the next thing, literally the same thing on the bottom, right? So it's not supposed to go up there. What the hell? I actually don't know what it was doing. Okay, there. And then we do the same thing over here. Make it tangent. Cool. And now we have the same thing, 2 tangent lines, right? So we can go in and cut this excess off over here and over here again. All right, and so is everyone at something that looks like this so far?
Yep.
All right, cool.
Yeah.
All right, sounds good. Okay. The next thing we can do, I'll show you guys another relationship. It's parallel, right? So one thing that's kind of obvious over here, I don't know if you could tell very well, but on my thing, you see how the space over here is a lot different than the thickness over there, right? So one thing you can do is put in a parallel relationship. So we know that if we want these two thicknesses to be equal on both ends over here, that these two lines should be parallel, right? Because obviously the reason that it's coming out thicker on one side is because they're not parallel. So you can go in and select these two lines and make them parallel, right? And it won't automatically do it on the bottom half. So if I click over here, see there's no relationship. It's just mathematically comes out that these two are also going to be parallel, right? Yeah. So if you click that, if you make those two parallel, you should get a more clean looking thing like this, right? Everyone have something that looks a little bit more symmetrical?
Can you go over the parallel again?
All right, yeah, cool. So you want so you see the gap, the difference in thickness on the sides over here, like from this side and that, right? So the way we get them to be equal is by making the line, this line and this line, the two bright blue lines, right? We can make them parallel, and that will make the thicknesses on both ends equal, right?
Okay.
Yeah.
Thank you.
So you click those two, and then he'll actually automatically assume which one you're like trying to do, which is pretty smart, right? So you see over here, parallels bold. So you can just click parallel over there, and now those two are parallel, right? And why is my thing pink? What? What the hell? I have never had that turn pink on me before. Oh, okay, that was weird. All right, sorry about that. Let me just redo that real quick. All right, cool. All right, so we're getting there, right? And then now we have something that actually looks pretty decent so far. We're making our way, right? The next thing we want to do is make these little bearing pockets, right? So actually, you know what? We can hold off for that for a second. We can first start making the thing, right? So now with this basic shape done, we could start on making the walls and stuff like that for this part, right? So I exit the sketch right here, and we can go to features and extrude boss and base, right? So start with this, right? You can start with doing the whole thing. Come on. Hold on, give me a second. Also select this area and that area. Yeah, right? So have those two areas selected. And then we could say, let's make this an eighth thick, right? So 0.125. Doesn't really matter how thick we make it right now. And now you can see we have something 3D, right? And then we still want to make another feature off of this. So if you go in over here and then click on the sketch, don't want to rename it. Click on the sketch and then do extrude boss again, right? We can now select a different area. I mean, it already assumes you want to do that outside area, right? But in case you wanted to change it, down here, selected contours, right? This will change like what part you're talking about. So you could select the inside area if you wanted. You can select the outside area if you wanted, and that is what we want, right? So the outside area. So make sure whichever one you want is correctly selected, right? And so you can just change that down here. And so now this one we want to make it a little bit thicker, right? So let's make this like about an inch, right? And so now in the preview, you can see we have a much thicker wall and also the bottom like that, right? Something like that. Is everyone good so far? Okay. So, oh, another thing actually I kind of forgot to mention. Okay, so before we continue on, let's handle something that's pretty important, right? So in sketches, have you guys been taught the difference between blue and black lines?
Oh,
No? Okay. So in sketches, there's a big difference between blue, black, yellow, and red lines. So red lines are obviously very bad. You do not want to see a red line. Red line basically means that something is very wrong, and like the computer just doesn't know how to make this in like how to mathematically make this whatever line you drew. And so typically that happens when you have something made and you have it like over here. We said that this is 4 inches, right? And I wrote over here 2.5 inches. And so like if I were to go in and say, okay, I want this point to and this point to also be 4 inches away, but I already wrote it as 2.5, right? So the computer's going to be like, what do you want me to do? Like, how can I make it both 2.5 and 4 inches at the same time? I can't do that, right? That will actually come up as a yellow error because that's what they called over constrained, right? So you see down here, it says underdefined. That's because we have these blue lines, right? So there's undefined, there's fully defined, over defined, and then just red, like error. So like if I were to delete this, for example, this 4 inches, and then I said make this the same size as this, but I never declared this, or this got deleted, and so now it's like, oh, I don't know how big to make that because I don't have a number. Then that would give me a red error because it's like, oh, something was deleted and now I lost information and now something's broken. So a lot of the time you get those red errors is when something gets deleted, right? Okay, but basically back to the main point, right? These blue lines mean that this is underdefined. And we need to basically figure out how it's underdefined and how we can fix it, right? So one of the easiest ways is to move stuff around and see in which ways we can move them, right? So if we click the center of this circle, we can see that this can move like that, right? We could also grab this line. This can move like that, right? And then we could also grab this line. This one doesn't move too much, right? So that's pretty good. This one over here as well doesn't move too much. And the reason they're not moving is because we set them to a certain diameter. So these things aren't going to get bigger, right? So if I try to make it bigger, it's not. It's going to stay at 4 inches. This one's going to stay at 2.5 inches. But this one over here never defined how big this circle can be, right? We only defined this one. So what we need to do is go in and say how big that they can be, right? So one easy way is getting the distance of how thick we want this thing, right? So we can go in and we can say something like, make it 125, right? Something thin, doesn't really matter, right? But now because we said how thick we want it, you can see the whole perimeter got thinner, right? And now the whole thing won't change. I can pull this one as much as I want. It won't change. I can pull this one as much as okay. It will move left and right, but that's that's something else. Right, but also that's another issue. You see, it can move left and right, right? So that's an issue. And then finally, the last one is this one can still move like this, right? And we basically have to tell the computer like everything, right? Literally everything. So one of the things we can do is go in and say, okay, hey, let's make this. This should be 4 plus 2.5 is 6.5. 6.5 divided by 2. Oh wait, I don't know what 6.5 divided by 2 is. So let me tell SolidWorks to do it for me, and it can, right? So it's pretty nice. It has math built in. Well, a little bit. You can't like type in log of 4.95 or whatever like that, but like 6 divided by 2 is pretty easy for SolidWorks. So you can type in 6/2 and it'll do 6 divided by 2. Or you can just type in 3.25 if you have the brain capacity, unlike me. Yeah, so that's that. So now that fixes our problems of this thing getting too long or too short. So the last one, it looks like, I'm trying to move this thing around, and the only way I can move it is left or right, right? So that means that's typically when we go in and we mate stuff to the origin, right? So I'm gonna click on the origin, and I'm gonna just pick one of these circles, right? Doesn't really matter which one, and I'm just gonna make them coincident, right? And now with them coincident, you can see that point move to the origin, and also everything's black now, right? And you can see down here, fully defined, right? So if I try to move this, it's not going anywhere. I try to move this, it's not going anywhere. I try to move this, it's not going anywhere. And I shouldn't expect it to, because it's all black, which means that it is fully defined and it is happy, right? So now if I go back out of the sketch, the 3D features followed it, right? So it should it's pretty good. Give me 1 second, sorry. Sorry, I just have a text I really need to respond to. Okay. All right, sounds good. So that's that. All right, so is everyone caught up so far and understand the difference between the different color lines?
I'm having a hard time extruding though.
Trying to what?
Extruding.
Oh, okay. All right, so you have the well, like what have you extruded so far? Like, what have you up to?
Like if I try to extrude one, I don't know how to extrude the other. Like having two different sizes.
The two different like components, right?
Yeah.
So all right, so you have this one first, right? So first you want to do like is the wait, hold on, whoops, not sketch, edit. Let me edit feature. Right. So first you want to do is the whole thing, right? Because that's gonna be like your back plate, right? Like your that makes sense?
Yeah.
Yeah, right. So you want to first extrude the whole thing. So that would get you this, right? So do you get this?
Let me do that real quick. Yeah, but it's a little thick.
Oh, then if you want, that's totally fine. But if you want, then just go over here, like click on the boss extrude, and this pencil with the blue and white squares. I don't know what you want to call them, right? That's how you go in and edit whatever you typed in, right? So if you want to make it thinner,
Right.
just change this one here,
Okay.
right? And so you can put whatever number you want. It's not too critical right now. And then so now you got something like this.
Yeah.
All right, cool. So now what you want to do is, let me just delete this so I could show you. Right. So click this little arrow by it, and then you should be able to see the sketch that you used to make this feature, right? The one that we just made, right?
Mhm.
So you can go over and just highlight it. You don't have to do anything. Just make sure it's selected, and
Yeah.
then go back to extrude, right? And then it should automatically know that you want to pick this area, but a lot of the times it won't, right? So you can go over here and you can see that you can like drop down selected contours, and selected contours basically is like what spaces do you want, right? So you can delete the sketch one if it wasn't correct, like you could delete it, right? And then you could go in and just click whatever lines you wanted. So I want the outermost one, and I want the innermost one, right? So if I don't select the innermost one, I'll just do the whole thing. So I do need to select the inside line. Oh, crap. And not deleted. There we go. Right? So if I select both of them, it does all the space in between the two, which is the wall that we want, right? And then I'm just going to go over here and put 1 inch for that. And then also merge, or else your thing will come out as like different bodies, which is kind of weird. I can show you what it looks like. All right, so if I don't merge it, you see like the little line in between the two. It makes a line there for some reason, and I don't know. It's just not very clean. you usually want to just merge the two. So make sure that something like this is on. Sometimes you don't want it on, but 90% of the time you do, right? And so now you should have something like this, right?
Yep.
All right, cool. Everyone else good? All right. I'm gonna just keep on going then. Okay, so now that's that half, right? And the next thing that we want to do is figure out the bearing holes, right? So we need to put in a little thing for a bearing, right? So I'm going to go and show you guys how to use the measurement tool real quick, right? So let's use this. All right, so here, I just opened this up, right? And this is a CAD of a bearing. I didn't make this. We get this from Timken, the people who make the bearings, right? They just have a whole bunch of these CAD files online for people like us, right? So now you guys don't have the part, but I'll show you the feature, right? And then you could just actually use it on the part itself, right? So over here, if you go to evaluate, right? Evaluate has a whole bunch of different tools on evaluating your part. So you could go over here to measure, right? And this measure tool is very, very helpful. Have you guys been shown this before? The measure tool?
I think we have a little bit though.
Okay. Oh, so here, I'll show you how to use it, right? So you go into measure, you just click it, and you get this little window that pops up, right? And so let's say I wanted to measure the distance from this line over to this line, right? So you could just hover right over it, and if it's selected, highlighted, you can select it, and then you click the other line, right? And so now you'll see these different colored lines that show up, and they have a whole bunch of different distances, right? First thing I notice is that it's in millimeters, and I do not want millimeters. So you can go in and click this one thing that says units/precision, all right? And you can use a document settings, but personally, I'm not a fan of that. I like to use custom ones because I can easily just swap between the two. And for some reason, the document only has 4 decimal places, which is okay. But like if you typically want as much as you can get, right? So I like to set this as high and as I can, and it only goes up to 8, so I set it to 8. Over here, you can pick what units you want. So I just swap between millimeters and inches a lot because bearings are always in millimeters. I don't know why, but they are always in millimeters. So I have to like swap between the two. So I select inches, and now all my stuff's in inches, right? So this is a very, very, very useful tool. You can check out a lot more than just this. It'll also tell you stuff about circles, right? So over here, I highlighted 2 semicircles, and it tells me the center to center distance between the two. But I can also get different information, like the minimum distance between the two, right? So it just goes from their edges to each other. And I could also check out stuff like the maximum distance, right? So it'll go out from the furthest point to the furthest point. And so a lot of this information is actually really, really useful. I just not in this scenario, but like trust me, it is. So I'll show you one thing, right? So I need to know how big that bearing is, so that way I can make a hole for it, right? And so let's say I didn't know how big it is, but I had this CAD part, right? So what I could go and do is I'll go to measure, and I can just highlight the outside of this. And for some reason, the way the computer generated this, it cut this up into 2 circles, right? So it gives us information about the radius of it because it's not a full circle, right? But I think we all know that the diameter is just 2 times the radius, right? So one thing you can notice is that this is a really funky number. But if we go over to millimeters, it is significantly less funky because I said these things are made in millimeters, right? But SolidWorks is really, really nice about swapping between 2 as long as you correctly enter your dimensions, right? So the radius is 23.5, which means that the diameter is 47 millimeters, right? So when I go into my other part, based off of my measurement, I know my hole has to be 47 millimeters, right? So I go over back here, and I want to make another sketch, right? So I'm going to be sketching on this face, the inside face of it. So I just click the inside face. And so now I can just start making some bearing holes, right? So I'll just make one here, and then I'll do the same thing, and let's make another one there. And these two will be the same, right? So again, I need these two things to line up. So I'm going to highlight the two centers and make them horizontal. So that's good. And then the next thing I want to do is, because these both will get the same bearing, we can actually just set them equal to each other, right? So that's this one over here, make equal, just an equal sign, right? And now if we increase one, the other one increases as well. And we can't really, we can move it left or right. So since we can move it left or right, we got to figure out how far apart we want it. And we will make that the same length as before. So it'd get that over there. 6.5 divided by 2, right? There we go. So now that is in the center of both of these semicircles. So I can't move these things left and right. And if you look closely, wow, it keeps getting smaller. But if you look closely, the crosses in the center are black, right? Which is a good thing, which means we can't move the location of each circle. The circle itself is blue. That tells us that we can change the diameter of it, right? So if I go in, you can see I can change the diameter, right? But the cross in the middle is black, which means I can't change the location of it. It's just kind of, I know that kind of seems a little bit complicated, but it makes a little bit more sense the more you get into some of this stuff, right? So since we set these two equal, and we know that we want them to be 47 millimeters, right? So we can just go over here, and then we can dimension them out. And like I said, SOLIDWORKS is really nice about the difference in units. So I can literally just go in and type 47 millimeters, right? As long as I put that millimeters in, it's going to know what I'm talking about, right? Because if I type in 47, just 47, it's going to think inches, and it's going to give me a 47-inch hole. That's not what I need, right? So we do that. Right, and then the next thing we could do, actually we need, exit sketch, right? And then we could go in and cut extrude, right? Oh, extruded cut. So do you guys know the difference between an extruded boss / an extruded cut, right? I think it's kind of in the name, in the picture, but basically the difference between the two is one generates like a shape, and the other one removes material from a shape, right? So we want to make bearing holes, so we need to remove material, right? So we go in here, and we could see the yellow area is what will be removed, right? And so it goes past the back, and that's fine. But let's say we added some more stuff back here, and it might cut that stuff out. If there was more stuff that back here, right? We don't really have anything, but let's say I had a really cool picture or something like that. This would have removed it, right? So what I also might want to do is use some of these features over here. So if you click over here where it says blind, right, direction 1, you click where it says blind, it shows you a couple different options. So what these different options do is change how you want to select the length of this thing, right? So I could click blind, and blind just basically means make it 1 inch no matter what. I don't care what it runs into, just make a hole or cut out material for 1 inch, right? And that's fine. Most of the time it's fine. But sometimes you want something to be nice and consistent, right? So let's say that here, I go back here. I'll make this, just for example, I'll make this 1 inch, right? And that did not go the right way. Man. The other way. There we go. I think. Did it not do it? Wait, what the hell? Okay, that's really weird. All right, I'm sorry about that, but basically, if this was less than what I made the length of it. So 0.125 divided by 2. Right. So let's say I only cut half the thickness of the back plate. Right. You see how it doesn't cut all the way through, right? That kind of makes sense. And that if I wanted to cut all the way through, I would have to make sure that that number is more than the thickness of that plate, right? So that would mean me going in measuring both of the sides. Another way I could do it is by clicking this blind and having a different option. Through all will go through everything that goes in its path, basically, right? So if I click through all, there's no more distance option for me to select because it's literally just going to go through everything, right? So now I have a hole that I need. A couple different options are up to next. So you can like click like up to the next cut, which is a little bit more complicated. I really don't use that. The only ones I pretty much use are through all and up to surface, right? And offset from surface. So like if I had so if I up to surface. So for example, right? If I had some nice features back here that I didn't want to get rid of, I could just click up to surface and click the back face of this thing, right? So I'll select this as my surface, and this hole will go all the way through this back wall up to this surface, right? So it will stop here and not get rid of anything past it because that's what I selected, right? There's also up to body, offset from surface, right? So I can click this, and then if I wanted it to go like another half an inch or so, I could. It's basically the same thing as up to surface. And then there's mid plane, which is kind of complex, and I haven't really used that one. But up to surface, through wall, and blind are like the ones that you're probably using 90% of the time, right? So so now we should have something that looks like this, right? Everyone following along still?
Yeah.
All right, that sounds good. So then, so then with that, the next thing that we could do is put in a little wall for the bearing, right? So I didn't really make this thick enough. Actually, you know what we could do? Yeah, you know what I'll do? I will start working on the backside, right? So I'll start working on the backside, right? So I could do another sketch over here, like that, right? And now we'll start working on the back because we have to make somewhere for that bearing to sit, and that's going to sit back here, right? So I'm going to make another circle here. Actually, here, let me first show you what I'm talking about. Okay, there we go. So you see like these little things that stick out, right? So this is what I was basically talking about from before, stuff you don't want to cut out, right? So if I put like my through all, it would have cut all of this, and I don't want to remove this stuff because this stuff is important, right? So what we want to make is something like this little pocket. So we first made the hole. Now we need to make the spot for the bearing to sit, right? So we're gonna make something simple like this little pocket right here. This one's a little bit more complicated because you have an oil seal that would sit like right here, but we don't really need to do the oil seal right now. So if I go back over here, right, I'm gonna add this circle in, and I can add this circle in, right? And then you saw, I don't know if you saw it, but it gave me the center to select from, right? So if I try to like hover around the middle of the circle, I might get a little bit lucky. Actually, if I just, no. Right there, yeah. But if you just like get a little bit lucky, it will highlight this little center for you, and you can just make a circle off of there, right? And then basically you can just do the same thing. Select both of these two, and you can set them equal to each other. So that way, the reason you want to do equal, because like I could just go in and say, oh, make this, I don't know, 1 inch. And then, oh, make this 1 inch, right? But sometimes you have a lot of different things that need to be the same dimension, and it really, really gets complicated, and you don't want to be making stuff with like a million parts that have to be similarly dimensional. Let me just show you for an example, right? It's like, this is what this looks like. You can see this is kind of like all it needs, but you can still see how much it needs, right? This is pretty complicated. I'll admit this is really, honestly, really complicated. But basically, if I had to go in here and say each one of these holes are a 1/4 inch, because I know they're all a 1/4 inch, right? You can only imagine how much worse this would be, right? And then also as well, each of these edges have to be apparently 0.31 radius, something like that. And they all have to have the same thing. But if I were to go in and label every single one, it would be pretty complicated, right? And pretty convoluted and annoying to even look at. So that's why we like to set things equal to each other and use constraints. That's how constraints are very, very helpful to make our lives like a million times easier and to look at this stuff, right? So yeah, that was just a quick little explanation on like why we even use those in the first place, right? So I'm going to select this one, and I'll set them equal to each other, right? And now we could go back in and looking at the bearing, right? So we need the wall to not touch this part, right? This surface over here is going to be spinning, while this surface over here is going to be staying still. So these two can't be touching. So we need it just a little bit bigger than this side over here. So again, we're going to go into the measure, right? And we can see that is 20.7 millimeters in radius, right? So then multiply that by 2, 41.4, right? So we need something that is just a little bit bigger than 41.4, but since it can't be touching on this surface, we need it smaller than 16.075 times 2, then 35 millimeters, right? So bigger than 41, smaller than 35, 33. Let's pick 35 millimeters because that's just in between, right? So we can go over here, features, sketch, 35 millimeters, right? So now we have a thing for 35 millimeters. And then also we need an outside wall because that's going to go over here somewhere. Like here, right? And then same thing on this side, because this has to connect to the case somehow. So we need a little bit of material that rests on this back surface, right? And you can also do the same thing, make these things the same size, make them equal, right? Okay. So now we know how big this inside is going to be, and we also have to say how big we want this. So what is this at now? 2.2. So let's make that 2.25. Because honestly, the overlap over here is honestly about fine, right? You can do a little bit of math if you really wanted it to be like 1/8 of an inch or something like that. But yeah, something like this looks about good. Okay, so is everyone caught up so far, or is that a little bit too fast? Okay. Sounds good then. So just about to finish up here. So then the last thing, one of the last things you need to do is extrude this out, right? So again, we're gonna go to features and then extrude, and then also make sure you had the sketch you were working on selected, right? So extrude, and then over here, let's make this 1/2 inch thick or so, like that, right? There we go. All right. So now we have these little back plates that this bearing, when we put it in, will be able to sit on, right? So the bearing sits here, and that way it's held in place, but it doesn't fall out the case, right? So that makes sense. And then last thing we can do that I'll show you real quick. Actually, let me make this a little bit bigger so that way it looks better. Let me just 0.5. There we go. All right, cool. Oh, that might not work over there. That's fine. All right, so last thing I'll show you guys real quick for right now is a fillet, right? So fillet just basically makes things contoured into each other really, really cleanly. So in a lot of these parts, there's this thing called stress concentrations, right? So basically, what they consist of are sharp corners and things like that. And so they're really, really dangerous because when you have a force that is focused in one area, you have high, very, very high stress, right? So that would mean that that area is a lot more prone to breaking off, and because like it's because it's a lot more prone to breaking off, you really want to avoid stuff like that. So one way to avoid having sharp corners is by adding in these fillets. Also, they look really nice. That's just another thing. But yeah, so we have these fillets. So basically, using this is it's not too hard. So you just click the two surfaces that you want to fillet together. So I'm going to do it on this one. I don't know if we have the space for it on this one because it looks kind of tight right here. But this one it should work, right? So I'll click this first edge right here. And you can see that it already goes in and just tries to do all the work. And you know what? Honestly, it's not looking too bad. It's not looking terrible, right? So I could just tell if I only really wanted it right here, I could be a little bit more specific. I don't only want to fillet all this surface, but just this surface to this surface. And that didn't really do what I wanted. Tangential propagation. No. Partial edge parameters. What the heck? Oh wait, you know why? I know why. I was not supposed to select the face. I was supposed to select the corner. There we go. That's why. I'm sorry. It's been a minute. But yeah. So you select the corner that you want, and you can see over here. It shows you a preview, right? You might not have preview selected. I think it's by default no preview for some reason. But if you click over here, full preview, it gives you a little yellow wireframe of what it should look like when you're done, right? So we can go in and say we want a radius of quarter inch or so, and you can see how much bigger it gets over there, right? And so voila, right? You can now see that we have a nice filleted edge. So the advantage over here is we no longer have the sharp corner like we do over here, right? This sharp corner is prone to having a snap right here, and which would mean that this entire bearing pocket would actually fall out, which is as crazy as it sounds. Yeah, it can't happen, right? But over here, now that we have a nice rounded fillet, there's a lot more real estate for the stresses to flow through, and instead of being all bunched up in one corner, the stress is really low because there's a lot more material to flow through over a larger area, and you decrease the chances of stuff breaking like that, right? So you could go in there and do that one, and then go in again, and then do this one over here, and it looks like we just have enough room. Wow, perfect. Oh, there you go. Okay, so that does fit. So if you really want to, we can just go back here, edit this one, and then just add that over there because they're both the same, right? So if these both are going to be a quarter inch, we can just select both of them. And there you go. So now those two are filleted. And now this bearing will have somewhere to sit and be happy. And then we can throw our gears in there. Some other stuff that we could have done that are a little bit complicated for right now that I don't really feel like we need to focus on. Right, so yeah, sure. Just unsuppress. Right. So these little bolt holes, these were complicated for some reason. I don't know how else to say it, but they were complicated for some reason. I don't know if you can tell just by how quirky they look. I don't even know how to describe it, but yeah, I don't know how or why they were difficult, but they were for some reason, and they don't really look very clean. And I think you can tell the amount of the lack of care that they got when they were made. But yeah, there's these also bolt holes that we could make because when we assemble the whole thing, we need to put bolts through them to connect the two halves, right? There's that. This one has a back plate because this end is not supposed to be open to the environment. This pocket just holds in the bearing. But over here, this one is open to the environment because this is where the axle will go in, and then that connects to the wheels, right? So this one is open while this one is not because this one has something going through the case, right? That's the outlet, if you want to call it, right? The other side has the inlet on this hole, and this side is covered. But yeah, and then there's also these holes in here. these are, as you can see, it says alignment pinhole, right? So when we manufacture these cases, it's very, very, very important that we get these two cases to line up. And if they're like any bit asymmetrical in the manufacturing process, then that it will be a terrible, terrible, terrible day, because we would have to remake the whole thing. And these cases really, really take us a long time to make, like a month at least. So it would suck if one of them didn't line up. So we have these things called alignment pins. And basically when we're manufacturing these cases, we put these little pins in there, and they are like precisionally made. So that way we can ensure that during manufacturing, if we put this thing in a jig, a setup, when it's machined, it will be in the correct orientation and not be like, it's like kind of skewed like this, or skewed like this. You know what I mean? It won't be in the machine like this, and it won't be in the machine like that. We'll make sure that it's perfectly level to how we want them, and so that way they both come out equal, right? And when we close them up, everything lines up even nicer, because it's very, very critical that these bearing holes line up, because if they don't line up, this thing won't close, and it will create a lot of friction to the point where things might explode. That's very bad. And so yeah, we have to ensure the safety of this thing. But yeah, that's pretty much the case, to be honest. There's really not too much different. Oh yeah, like I said, over here there is this oil seal, like little well. And so basically when there's oil inside these cases, right? And so since we have a hole going out into the open environment, we need to make sure that there's a seal here, so that way nothing gets in and nothing comes out. Because if there's rocks in oil, that's a terrible day. That's a very, very, very bad day. And if oil gets out, that would also suck for the gears. So to ensure that we have a proper seal on rotating parts, we use these things called rotary shaft seals, and they basically are just like little rubber parts that just grip around a rotating shaft, our axle in this case. And they have like these springs inside them that just clamp around the shaft. So that way that way it creates a nice seal. So the oil doesn't get in, nothing comes out, and the thing's made out of rubber. So when the axle rotates, it doesn't like get too much friction. But yeah, that's pretty much how this case is made. Right. So, are there any final questions from anybody? Everybody get everything? Everyone okay? Sounds good. All right. All right. So then I guess that's really pretty much it for right now. I think that should have covered a nice section of this. Okay, so I hope that this was helpful for you guys. I'm sorry that this can't be in person. In person, and would have just been a lot easier to just like look over your shoulder. But yeah, I hope that you guys were able to get something out of this. Next week, I want to try to see if you guys can get those miter examples. Those little example. Yeah, that example I gave you. It's not like a final grade. I'm not gonna criticize you if you get too busy. It's okay. I just wanted for you guys, so that way you can get practice before you go in and have to make something else that goes on the car, right? So yeah, it's for you guys. Any questions you have with like making something or whatever like that, any like SolidWorks questions, don't be hesitant to ask. Like I'll probably be able to answer my phone. And yeah, so I'm aiming to have that this Saturday, and then we could probably get started on tasks pretty soon. Okay. So that's really all I had for this meeting. So if there isn't any final questions, you guys are free to go.
I'm sorry to delay it, but can you go over the fillet again? Because I
Fillet?
messed up. Yeah.
Oh yeah, no problem, no problem. All right, so here. Okay, so over here, let me delete this. Okay, so you got something that looks like this,
Yep.
right? Okay, so you click fillet or fillet. I keep on saying fillet. Fillet, right? It's fillet. And so what you want to do is you want to click the edges you want to smooth out, right? So for example, I want to click on this edge and I want this edge, right? And you can see the little preview it gives you, right? Does it show up for you?
No, it doesn't.
Okay, is it full preview selected over here?
Oh, there you go.
Yeah, right?
Yeah. Yeah.
Yeah, all right. And then now with those two selected, you can just change the radius out, like how steep you want it, right? So I can make it bigger if I want it over there.
It also curves the top for me.
The top like this.
Yeah.
Did you select the face or did you select the edge?
The edge.
Are you sure? Let me see, cause
I'll do it again.
yeah, because I think that should only happen if you select. Like yours looks like this, right?
Yep.
Yeah. And is your whole face selected blue like this?
Yeah.
Oh no, then
I tried it again.
Then you're clicking the face. You want to click the edge,
Oh,
right?
sorry. Okay.
Yeah. You see over here how
Okay.
yeah. Do you see you only click that edge, the whole thing goes.
Okay.
Yeah. And then you can also do the same thing on this half. And
All right.
then that should be that. All right.
Thanks.
All right, yeah, cool, no problem. All right, so like I said, there's no final questions or anything like that. Then yeah, you guys are free to go. Let me just end this.
All right, thank you. Bye.
Yeah, no problem, guys. All right, have a nice weekend, man.
You too. Have a good one.
Yeah, you too.